All right, let's keep going. Let's talk more about loops. So there's more to learn. Let's talk about some words that you can say inside of loops. These two things, they only work inside of loops, and they control how the loops work. All right, so continue, that's the first one. You just say it on a line by itself, and it skips over one iteration of the loop. So an iteration is just an execution of its body. So it skips over one body of the loop and just goes straight to the top. Goes straight to the top to check the condition again to potentially restart a new iteration of the loop, a new execution of its body. Okay, so let me show that to you. Let's make a for loop that would normally print from 1 to 10, but let's say that like we hate the number 3, so we'll skip over 3 with continue. Okay, so I'll make a new file. I'll call it continue and break.cpp. So here, let's start with just a normal for loop that prints from 1 to 10. 1, I less than equal to 10, I plus plus. So this is a normal for loop, right? That prints from 1 to 10. There it goes, it did the right thing. And now let's say that for some reason, like we really don't like the number 3, and so we'd like to skip over printing 3. We just want to keep the loop going, like print the later numbers though, but we don't like the number 3. So we want to control whether this line gets printed when I is 3. So here's what we'll do. We'll say if I is equal to 3 right now, then just continue the loop, please. For a for loop, it'll go to the what's it called? It'll go straight to the increment part, not straight to the condition, because it still needs to like go and finish the loop. All right. So if this were a while loop, continue would just go straight back to the top, and all you need to do with a while loop is go straight to the condition. All right. But for a for loop, it still does the increment, okay, and then goes back to the condition. But the second you say continue, it skips over whatever was left of the body, essentially. That's all it does, and it does whatever it would normally do after that. All right, like the increment and then the condition. So what this will do, like when I is 3, it will not run this. It will not print it when I is 3. It will go straight to make it 4 and try again with 4. So just continue the loop from here. Do not do the rest of the body. Okay, so it goes 1, 2, 4 now. That's what continue does. It lets the loop continue. All right. Break, though, stops the entire loop. It exits the closest loop you're in. I'll show you what that means one day. But here, let's do a while loop for that. Break is very, very useful when you're not really sure how many times you want to execute. Like, only when a certain special condition is like satisfied do you want to stop your loop. That's what break is great for. It will stop your loop whenever you're ready. All right. So let's do a while loop that stops when the user tells us something. Like it could potentially be an infinite loop otherwise. So let's do an example of that. Let's make a loop that would normally be infinite, right? While true. So the condition is always true. It will never stop unless we somehow get out of it. Stop the program or do this thing called break. All right. So let's ask the user to enter a character. Like maybe they want, like this is an option for them to choose from. Like Q means quit. We'll interpret Q as meaning quit. So we're going to get a character from the user with CN, and like maybe normally what we want to do with that is like process their query. Like, I don't know, I'll just spit it back out to them. But you could imagine that you're doing something fancy with whatever the character you get, and just like keep doing it. Like it's like an ATM machine. It keeps working until you say I'm done. But if they typed Q, that was their little exit button, then if C was Q, I want to break. All right, so break is going to stop the loop. Stop the loop completely. All right, let me show that to you. Do I want to do a new line? And so that's different from continue. All right, so what continue did was it skipped the rest of the loop body and goes to the next iteration. All right, so that's an important word to remember, but it doesn't stop the loop. Break stops the entire loop. Okay, so let's have that run. That's going to ask me for characters. So I type A, B, C, D. It'll just like, this is false. So it just skips over it and then goes to here and just like redoes it forever and ever until the end of time. Like I can keep typing A all day long and it's never going to stop. But eventually if I type Q, lowercase q, it's going to be like, okay, that was equal. I will break out of the loop, which stops the whole thing. It would come down here. If there was more code, it would run it, but it just ends the program with the return 0 right now. But that's how break works. All right, it'll eventually stop the loop when you're ready under some condition. And so you'll see a lot of loops that look like this. They're infinite, and they have a break inside of them under some fancy condition is only when they stop. Okay? So that is continue and break there. Very useful. Take advantage of them. Now you know. I'd like to just do a fancier example now. Let's talk about calculating a nice mathematical constant. Let's calculate the number e. All right, you know that from math class, it's like 2.71 whatever. So here is the mathematical formula for e. It's an infinite series. If you wanted it infinitely precise, but we don't need it infinitely precise. Let's just calculate e to a few decimal places. All right. So in general, you do this thing called a summation up to n being infinity. All right. So this syntax, by the way, it's kind of like a mathematical for loop if you think about it. It's just like, all right, start n at 0 and just add. Capital sigma for sum. Add up all the values when n is 0 and n is 1, n is 2, n is 3, all the way to n being infinity. Okay. So if you did that, apparently, you get the number e exactly. Like some mathematicians figure that out, and we're going to use that to our advantage. All right. So I just need to do this, right? I need to calculate this sum, adding up all these things. Let's go up to n being, let's just say 100. That's plenty of precision for us. Let's go up to n equals 100. All right, that's plenty for a double, because it'll be a decimal number, right? So let's just add up 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial, all the way to 1 over 100 factorial. Okay, and that will be a very, very good approximation for the mathematical constant e. All right, so this exclamation point means factorial. I'm going to have to calculate that for us. All right, so remember what that means, right? 5 factorial is equal to 5 times 4 times 3 times 2 times 1. That's important, and that gives us e somehow in this weird way. So what I'm going to have to do is the following, right? I want to calculate a sum. We've done that already. I'll just start a sum variable at 0 and just like shove things into it. 0.0, I guess, if it's a double. And I'll just like in a loop, I'll change the value of this n. I can keep it called n. I'll translate it from math to computer science. And I'll make like a variable called current term. It's like it's the term of my summation that I'm working on right now that I want to add into my sum. And what is it equal to always? It's equal to like 1 over whatever my current value of n is, and ranges. Current term equals, I guess 1.0, right, over the factorial of n, if I had that function, okay? And just like calculate that and just shove it into sum 100 times, or 101 times, going from 0 to 100. And do you see, if I did that, I just kept on adding it into sum would be a good approximation of e. So let's do that. All right, I will have to though. There is no factorial function in the CMath library or anything, so I have to make a factorial function. So you can look away if you're scared, but I'm going to have to do that. All right, and apparently it has to give back a double because I can't use ints, because ints can't hold giant factorials like of 100. But yeah, let me secretly write a factorial function as well. I'm getting ahead of us, but it is necessary here. So you can look ahead, or you can look away, or you can look at my code and learn a little bit ahead of time. So I'll call this, I guess I can just call it e, right? e.cpp. So, okay, here's what I want to do, pretending I had a factorial function. I want to do a loop, right, from 0 to 100 for some n variable, and then start a sum variable at 0. So a for loop is great for that, right? So for int n equals 0, n ranges all the way to 100 by ones, n plus plus, so n goes from 0 to 100 in that order. I just want to keep on adding 1 over 0 factorial plus 1 over 1 factorial. It's just 1 over n factorial each time. So that's my current term of my sequence, of my summation. It's 1 over the factorial of that n, okay? And once I calculate that, I want to add it into my sum, whatever it is right now. 1 over 0 factorial, 1 over 1 factorial, 1 over 2 factorial. Keep on putting it into the sum variable. Sum plus equals current term, right? And so remember that that is shorthand for sum equals sum plus current term. So that's perfect. That's what I need. And then my editor is complaining because factorial does not exist yet. So we need to do that. And then once this is done, like, it's got a very, very good approximation for factorial in the sum variable. This formula converges very quickly. So n equals 100 is even overkill for the double type in C++. So it's very, very precise. It will be exactly e for all intents and purposes. So yeah, let's calculate e using this factorial function. So look away if you'd like, but here's how you make a function secretly. I'll teach you this in depth later. But factorial, its name is factorial. It takes what you want to take the factorial of, so like an n, and then it returns, it gives back the factorial. I want to return as a double because I need to return very large numbers. All right, so the factorial of a number is just like a bunch of multiplications, right? Factorial of n is like n times n minus 1 times n minus 2, or thought differently, it's 1 times 2 times 3 times 4 all the way to n. There's a big long product, right? And so in a variable, like I'll call it results, I guess, I'm going to start that at 1, and I'll just keep multiplying into this result variable. Can't start it at 0, because then it would just stay 0. So if I want to do a bunch of multiplications, I'll start with 1, rather than a bunch of summings. Sums need to start at 0, though. All right, and then I'll do some work, and then eventually result will hold my answer, and then I'll give that back by saying return. Return results. Okay, the hard work is here. So I need to loop from 1 to n, essentially. For int I equals 1, I is less than or equal to n, I plus plus, then result equals result times I, essentially. So that'll just multiply 1 times 2 times 3 all the way to n into result, give it back. There's your factorial. All right, that's the secret. If you looked away, you can look back again. I'll eventually teach you how to make your own functions, but we needed that. And then, bam, look at it. That's perfectly precise e. I think 100 was overkill. We could have gone to like 10 or something probably. You could check that, see if it's still accurate. But yeah, that is a very, very good example of how to use a loop for something interesting. Okay, so yeah, a lot of things. You can calculate pi in a similar way. There's a formula somewhere. You can go, there's a million different formulas for pi. You can do the same thing, and I think that's a great way to practice. All right, I'd be happy to help you. But yeah, I think that's what I wanted to say about this example. It's a fun use of loops, I think. What else? I do just want to pause and make sure you remember loops. So maybe go back to the slides from last time, go back to my code. But what I'd like you to do now is, if you can, go somewhere, go on the server, or take out a piece of paper, it doesn't matter. But pause the video and try to write down a very good, subtle example of an infinite loop, all right? That's what I want you to do. Go write a subtle example of an infinite loop just to yourself. But don't say while true, that's too easy. Make it very hard. Like, try to think of all the ways that you could mess up, because if you do that, if you think of all the ways you could mess up, it will help you not make those mistakes, right? That's why I want to pause and have you do that. But yeah, give it a try. Some easy ones are like, you got the wrong condition, or maybe you forget the increment part of your loop, even if it's a while loop. Still got to include that stuff, right? So think about that. I think that's important. But we'll come back now after you've tried that, okay? All right, so another thing that I can show you is, remember that pause function that I used in my karaoke example on the first day of class? Let's use that to our advantage to make some animation. I think that'll be fun. We can use loops for that as well. So like, all animation is, right, on a screen, is you're just showing a bunch of pictures really quickly, right? It's like maybe you've made a flip book in like elementary school when you got bored one day like I did. But you just like, you draw one thing, and then you show that for a split second, you wait, and then you draw another thing, you show that for a little bit amount of time. Yeah, that's all animation is. And so we can control that using like a pause function. Like, all right, print something to the screen, pause, wait, keep it there for a second, then print another thing to the screen. That will produce animation, won't it? That's kind of cool. So yeah, let me steal my pause function from the first day of class, and then I'll make a little animated star just falling. It's like snow's falling softly on the terminal, I guess. Animation, that is spelled correctly, I think. And then yeah, let me include real quick the karaoke example, all this stuff for pause. I had to look this up myself, so don't worry too much about it. But now we can call a pause function, give it a bunch of seconds to sleep for, and it stops the program. All right, so there's that. And yeah, let's print some stars. So let's just make a loop that prints 10 stars to the screen. I is less than or equal to 10, I plus plus, and then I'll see out a star, and then a new line. This is just going to print 10 lines of stars right now. I need to make it fancier, but I want to show you a few things. So first, we can all agree that this is a line of 10 stars, right? This is kind of more typing than it could have been. Programmers like to be lazy, and so I could have typed one less key on my keyboard, but got the same effect by doing the following. I could start at 0 and then say less than instead of less than or equal to. Do you see how this will do the same thing? Still a line of 10 stars. We're just using I to go from 0 to 9 instead of 1 to 10. All right, so I'll be doing loops a lot like this from now on. This is one less key for me to press. All right, we're very, very lazy as computer scientists, so this still does the same thing. And now, watch what happens if I pause in between each printing of a star. It's going to print a star and then pause, print a star and then pause. It's going to loop that 10 times. Boop. Look at it, it's animating. It's animating the star falling, I guess. That's pretty cute. All right, so I think that's fun. All right, so that's animation. One other cool thing that I can show you is if I include the string library, I can create a string on the fly like this. It's kind of cool. This'll have it like our little star, little piece of snow, like floating in the wind sideways, being blown by the wind to the right. So here's what I can do. I can say, you can say the word string to create a string based out of it'll like duplicate a bunch of characters. So I'd like to duplicate many space characters. So the first time it'll make nothing. It'll make the empty string, because that's 0 space characters when I is 0. But then when I is 1, it'll make 1 space character and make it as a string. And the next time it'll make 2 space characters, put it together as a big string with 2 spaces. Kind of see that? So that's pretty useful. It will just duplicate a character a bunch of times and create that string for me. And here, look at it. So 2 spaces, 3 spaces, 4 spaces, all the way to 9 spaces, right? And that it looks like it's being blown in the wind. It's so cute. So yeah, I think that's a fun new thing to learn. What else? Yeah, I think that's all that I have for that example. I think that's useful knowledge for your brain. And now I'd like to switch gears to something similar yet different. You knew this was coming. You can put loops inside of loops. You can put whatever code you want, right? Just like if statements inside of if statements, totally fine. This is fair game. These are just curly braces, right? You can put whatever code you want in there, including more loops. And this is difficult, all right? This is a traditionally difficult concept in CSCI 40, so pay a little bit extra attention, more than you normally would, all right? So let's do it. I promise that you will be able to understand it, but this is where we're going, all right? You can put loops inside of loops, all right? So think about this. You can have like a while loop that messes with like an I variable and has its I variable range for like 1, 2, 3, 4, 5. Then you can do the same for an inner loop that can use some other variable. Like maybe it involves a j that like iterates from 1, 2, and 3. Like it ranges over all those things. What I want you to think about is this. Maybe these words won't make a lot of sense right now, but come back after you've watched this lecture. It should make sense, all right? Watch it twice if you have to. But here's what's going to happen. You're in your while loop, you're running an iteration of the body of the while loop. It just means run all this code, right? So essentially, you think of anything in here as one big long thing to do, including a while loop. It's just something that needs to run as part of the outer loop's body, okay? That's kind of how I want you to think about it. It's like whenever you're running the body of the loop, like it's going to go 5 times essentially, it's going to run this whole thing, right? It's just like this is a piece of code that needs to get run. So during each iteration of the outer loop's body, the inner loop executes completely. It runs this entire while loop every time it runs the body. Does that make sense? That's the secret. And so it's going to go j123 when I is 1. It's going to go j123 when I is 2. That's just how that works, right? It's going to run the whole entire loop. Have j go all the way it needs to go every time it runs the body. All right? That's what happens. And so here's a good example of that, okay? This is a good running example, I think. So we're going to go very slowly through this to prove and understand like why it prints exactly this. So here's the code on the left. This is exactly what it prints on the right. All right, I'm gonna do my best to explain it slowly. Okay, so let's walk through it. So first of all, let's break down every loop. So this is an outer loop, and then inside of it's got an inner loop. All right, so an outer loop and an inner loop that use different variables. That's very important. Otherwise, it gets weird. But all right, what does this loop by itself just do? It's messing with an I variable. How many times will it run its body is the question. This executes its body. Do you see it? Executes its body. I will range from 0, 1, 2, 3, all the way to 4, right? Not including 5, because it's strictly less than. It executes its body exactly 5 times. Okay? That's what you see there. 5 times. And then, all right, so that means 5 times it's going to run its body. 5 times it's going to run this whole darn for loop. Does that make sense? That's what it's going to do. 5 times it will run this whole thing, and this loop has to finish, right? In order for it to run, it must like run to completion. So, all right, let's talk about what this loop is going to do. It's got a j variable that does kind of the same thing, right? It's going to execute its own body 5 times. Also, executes its body 5 times. And then it somehow prints out this in that exact order. Its body 5 times. Okay, so my question for you now is, let's see, with that in mind, do you kind of see how many times this inner line is going to get run? That's important to think about. You see how many times that's going to get run? Because that's going to lead into your knowledge of nested loops. This is called a nested loop, by the way. Like you're nesting this one within another one. How many times is this line right here going to get run? Do you see it? I mean, I guess you can count the picture on the right, but can you kind of understand, like, all right, when I is 0, this is going to go 5 times. When I is 1, this is going to go another 5 times. It's going to go 25 times. Does that make sense? This line gets executed 25 times. That is not spelled very well. Five times 5, which equals 25, right? 25 times. And you can verify that with the picture on the right and just start counting the lines. But that tells us something, right? This is going 5 times, this is going 5 times, which means somehow this is going 25 times. Now, let me do my best to explain that now, right? So here's what's going to happen, and this is also why it prints in this order. So the very first thing this loop is going to do, I'm going to draw exactly how this runs. A great thing that you could also do is feed this into that C++ tutor website. It would draw exactly what's going to happen and show you the variables changing as well. So the very first thing that happens when like we come to this code and C++ wants to run it is, all right, it does the initialization of the loop, right? That's what it sees. It's on this line. I got a loop. I'm running it for the first time, so it does initialization. Int I equals 0. So there's I, starts at 0. Cool. Condition body increment, right? So is I less than 5? Yes. So it's going to run the whole body, right? So now we're in here. We're running all this. It's a for loop, so we get to the start of it. And it's like, all right, how does C++ run a for loop? Initialization first. So we're going to hit this line, int j equals 0. Cool. Int j equals 0. Is 0 less than 5? Sure. All right, so we run the body and do the increment. So we print 0, 0. There it is. Do you see it? We print 0, 0, and then it's j++. That's my increment. 1. Does that make sense? Let me come back to this. Condition body increment. This whole loop needs to run to completion. That's what it means to run all the body, okay, of that outer loop. So, all right, 1's less than 5, so body increment. We're going to print 0, 1. See that? Increment to 2. Still, 2 is less than 5. Do you see why it's going to print in that order now? So it's going to print 0, 2, make it 3, 0, 3. It'll go all the way, right? 0, 3 to 0, 4. And then it'll make it 5, right? Plus, plus. One last time. Check the condition. Now it's 5. 5 is not less than 5, so it stops the loop. It's done, which means we've essentially run this entire body, right? It's like, think of it as one statement. We finished the statement, okay? It's finished. Now we're down here. We've hit the end of our body of our outer loop. And so that's what happened, right? It was condition, body, that big long thing, then increment. So now it's increment time for I. So also, by the way, we hit this closing curly brace. We're done with that inner loop. J is gone. J has been dead for quite a while, I guess, since this curly brace has been hit. But now we're at this one, so now it's increment I to 1 now, and now it's condition body increment again. See that? So you see why 1 is for I now, and then we run this entire loop all over again. You see why it's going to multiply that work there? So that makes another J, right? Starting at 0, now it's 1, 0. I think you can imagine, right? Body increment, condition body increment. So 0, 0, 0, 1, 0, 2, or sorry, 1, 0, 1, 1, 1, 2. That's what I is holding now. 1, 3, 1, 4. And then it makes it 5, of course, which stops the loop. See that? So that's what happens there. And like that, then it's done, right? It's done with this outer loop. Or sorry, it's done with the inner loop. Done with the inner loop, which means J is gone. And we're done with one other iteration of this entire like outer loop body. We've hit here now. So we're back to increment. I becomes 2, because it's always condition body increment. So, all right, it's 2 less than 5, sure. Condition body increment. So I think you can see now, right? Y is going to be 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. This is the J changing, and I is staying the same. It's waiting for that inner loop to finish. Same for the 3s, same for the 4s. All right? So eventually we're going to get to here. Like I is 3, I is 4. It's the last value of it. And so like 4 is less than 5. Condition body. We do it one last time, right? Make a new J starting at 0. We print 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. And then we increment it one more time, which stops that loop. We're done with it. And then we hit here. We do I++, make it 5. Now this is false, which means we're done with the whole darn thing. Do you see why it's doing it? All right, why it's doing it like this? Do you see why this is getting multiplied, right? It's getting executed 25 times in total in this order for those values. Does that make sense? So this is the very last one, 4, 4, 0, 0, all the way to 4, 4 with everything in between that all these values ranged through. Okay? This is a good slide to study. Stare at it until you get it. Ask me lots of questions, please. All right? So this knowledge is interesting knowledge. Like we notice that like when we have a nested loop, this inner thing is getting multiplied. Like if this outer one went 5 times and this inner one went 5 times, this is going 25 times because of that. That's interesting, useful knowledge. So that's our first key idea of nested loops. We notice that they multiply the work done in the innermost body. Okay, so let's use that to draw a box of stars rather than just like a line of stars or something. So I'll draw a box of stars for you now, and let's get at it. All right, so it's going to turn into a nested loop, and actually I'll show you that just comes up naturally. All right, so let's think about it. Let's break down the problem like this. Let's say that we want to break down the problem like this. Do you see how you would solve the draw a 4x4 box problem if you did the following? If you thought of each line as a chunk, and then you just repeatedly, right, 4 times, you printed a chunk. Does that make sense? That's not even a nested loop yet. Do you see how that would work? So that's essentially this. Do 4 times, print this chunk, right? Do you see that would give you your box of stars? So do 4 times, print 4 stars and a new line. And a new line. I haven't even shown you a nested loop yet, have I? This is just a normal loop. This is called pseudocode, by the way. It's not real C++, but I believe that you could translate this into C++, right? So yeah, that's one way to draw this 4x4 box, right? And then, like if we just repeated this 4 times, the following. Print 4 stars and a new line. Well, do you see how you could expand this now? How do you print 4 stars and a new line? Well, that's just, well, you have to do 4 times, right? How do you print 4 stars and a new line? That is the following, right? It is do 4 times, again, printing a single star. Print a single star, and then after that's finished, like, then it's time to print a new line. So just like shove that back into this, like you still needed that outer one. Do you see how it naturally becomes a nested loop? Do 4 times. Whee! Does that kind of make sense? I hope it does. Do yell at me if it does not, but like, just like naturally we discover that we need a nested loop. And I hope you can see how you can translate this to C++ in a similar style as this. It's like we need a loop that iterates 4 times and another loop that iterates 4 times inside it. So that'll print 4 stars and a new line. Just do that 4 times, we got a 4x4 box. It's beautiful, all right? And so kind of what happened, like what this will turn into in C++ is a loop like this. The outer loop here is kind of worrying about which line that we're on. It's like 4 times do the current line, essentially. So the outer loop, its job is going to be to worry about which line we're on. And the inner loop is kind of like which column we're on, essentially, if we're doing a box. So the inner loop is worrying about like what we're doing on each line, printing that single line of stars, okay? Print a single line of stars. Okay, so let's take this code, or this pseudocode, and translate it to real code, to real C++. And we'll see it working with our nested loops. And we know, based on the way we did it, that it's going to work, right? This is for sure going to make a 4x4 box of stars. And you can change the number 4 to make any kind of box of stars you want. Maybe you can ask the user, huh? So let's see. I'm going to need to do this now. I want to make a loop that executes its body 4 times, right? That's what I'd like to do. So I'll make this loop. Int I equals 0, I is less than 4, I plus plus. I'm not really ever going to print I, I'm just using it to keep track of how many times I'm doing something. So 0 to 3 is fine, as long as it's 4 times, right? So this executes the body 4 times. And then, all right, so that was my do 4 times, and then I'm working on this. What goes inside? What gets repeated 4 times? Well, it's another do 4 times of printing a single star, because that'll print 4 stars at once. So I need to loop, right? Print 4 stars on a new line. That's exactly what I want here. Print 4 stars on a new line. This stuff. But how do you do that? Well, it's another loop, right? Do 4 times printing a single star, or int j equals 0, j is less than 4, j plus plus. See out a single star. I guess I'll use single characters, why not? And then, see, that's 4 stars. I still need my new line, but not repeated, just one new line, right? So there it is. And I guess if I'm using single quotes and characters, let's just keep that pattern going. There. Does that make sense? That was me translating this, or really this, and then like expanding upon it, right? That's a good way to program and to figure out your algorithms. It's like break it down, slowly but surely. And look at it. It's beautiful. 4x4 box. All right. So that's very, very useful. All right. Very, very good to know. And it's a great first example of a nested loop. With that, I'll go back to my code and show it to you for a second. But what I want you to do now is try to modify it. So take this code, here it is, write it down if you need it. I want you to change it up, all right? So instead of printing a box that is all filled in, I want you to print a hollow box, all right? Modify it to instead print this, all right? Do you see how you might do it? I'll give you a hint before I send you off. So if you think about it, what's happening when it's printing is, again, the outer loop is worrying about which line you're on. So when I is 0, you're on this line. When I is 1, you're on this line. When I is 2, you're on this line. I is 3, you're on this line. And then your inner loop is figuring out like which star of the line are you printing right now, essentially, at least for the old one. You're going to change that, of course. Like when j is 0, you're on this column. When j is 1, you're on this column. When j is 2, you're on this column. When j is 3, you're on this column. Instead of stars, here you want spaces, because that would move you along, right? That's my hint to you. All right, see if you can take my code, change it up, and modify it so that it prints a hollow box of 4 stars. All right, hopefully you gave it a good try. Do yell at me if you have any questions about it, but the secret's going to be is just like, don't always print a star, sometimes print a space. So you're going to have to control whether you print a space or a star, and that just screams, right, if else. So we need an if-else statement here for sure. we want to print a space when like we're within one of these, right? When it's I is 1, j is 1, when I is 1, j is 2, when I is 2, j is 1, when I is 2, j is 2. If any of those are true, right? Those are the 4 cases when I want to print a space over a star. So like you can think about that. You can try and simplify that. It's like mathematically, what do I want? I want to print a space when the following is true, right? When I is within the range 1 and 2, and j is also within the range 1 and 2. Do you see how like mathematically this is picking out all of these cases? Like the 1, 1, the 1, 2, 2, 1, 2, 2 for I and j. Well, sadly, you cannot do this in C++. This is like, you can do it in math to like talk about a range, but you can't do it in C++. At least for the and, you can change the and into these ampersands. That'll be perfect. But like this, sadly, you can't do this. You can't be like 1 less than or equal to I less than or equal to 2. Unfortunately, that does not work. It does in Python though, but not C++. So instead of this, what you must do instead is check both of these sides separately and just and them together. So it's like, this is how you, to get this instead, you'd have to do is 1 less than or equal to I and is I less than or equal to 2. That will give you this check. Is I between 1 and 2? Okay, does that make sense? That's the secret. So you have to do that for this one as well. It's like if all that's true, it's just going to be a bunch of ands. That's what we're checking. Then we're printing the space. So this is one way to do it. This is not the only way to do it. You could have checked for, should I be printing a star right now, rather than should I be printing a space right now? So yeah, let's take this and put it into a condition. All right, so if this is true and this is true. So you can flip this the other way if you don't like the numbers first. Be like, if I is greater than or equal to 1 and I is less than or equal to 2, so it's between 1 and 2. I guess because it's just two numbers, you could have been equals, equals, equals as well. That would have worked. And then and, but you have to or them in that case. Let's see. And then also, is j within the proper range? So double ampersand. You would think that by now I'd be really good at drawing ampersands, but no, I'm still not. So, and then also the same is true for j. I have to think every time I draw one of these. There we go. That was a good looking one for once. And then j is less than or equal to 2. All right, so if all those things are true at once, then we're within here. Does that make sense for I and j? So if that's all true, then it's space-time, else it's star time. Yeah. That's all we need to change. That'll do it. So here. Well, let's take a look. I guess I want to separate my boxes, so let's do a new line for separation here. And then, all right, so instead of this, instead of always printing a star, sometimes print a star, sometimes print a space. We got to check, right? Check to see if we're in the middle. If we are, it's space, not star. So if all this is true, if I is between 1 and 2, and so is j. So that's everything we wrote down. If that's true, then it's space-time. Else, otherwise, star time. All right, so that's picking out whether or not we're in the middle. And then everything else is the same. It's just like, right, we're printing something for this current ij value. It's either a space or a star. And there we go. Look at it. Beautiful. It's a little like, it's taller than you would think because characters on the terminal are like twice as tall as they are wide. But it works. It did it. Cool. Let's see. I think that's all that I wanted to say for that example. So is that what you got? Is that how you did it? There's other ways to check for it. There's a bunch of different ways to do the same thing in programming, which makes it more fun, I guess. So yeah, that's, I think, all that I wanted to say. Please yell at me if you have any questions about this example. This is a good example to check to make sure you're understanding things. So do ask me if you need any hints or help. All right, so now let's talk about triangles. So we got boxes down now, don't we? So let's talk about triangles now. How would we draw let's do a left-leaning right triangle. So it's like this, right? There's the angle. Leaning to the left, though. We can do this with nested loops, all right? We can modify this code. Surprisingly, we can modify this to not do a box, but to do a triangle. Let's figure this out together. So we can take most of our code from before. Here is the box code. It's like, it's going to look very, very similar, right? But instead, it's not always 4 stars on a line, is it? That's the one thing that changes. Like, we're still going 4 lines, so this like outer loop still correct. Like, I equals 0, we're on this line. I equals 1, we're on this line. I equals 2, we're on this line. I equals 3, we're on this line. And now the trick is, we need a piece of code that we can repeat, but somehow, when I is 0, it prints 1 star. When I is 2, it prints 2 stars. When I is 3, or when I is 2, it prints 3 stars. Do you see what you might be able to do? So like, you need to write some code that repeats, like this, like draw blank stars, because that's what you're doing on each line, right? Draw blank stars. Like, you need to do that. You need to repeat blank. And you have to fill in the blank with the same thing, because you're repeating this code in a loop, right? It's like, what would you put for this blank that's always the same, right? You cannot change, like, this can't be like 1, this can't be 2. You just can't hard code it. You have to put some expression here that's always the same, because we're repeating it, but like on this line, somehow it's going to turn into 1 star. On this line, somehow it turns into 2 stars. Does that make sense? Because you can't change, like, you must use the same thing here. Like, you're repeating the same code. So like, you have to fill this blank in with the same thing 4 times, essentially. What will it be? What could you put here that's like going to give you 1 when I is 0, 2 when I is 1, 3 when I is 2? Do you see it? On each line, what do I want to do? What do I want to repeat? I want to draw I plus 1 stars, don't I? Because I could do that. That's what I can repeat each time, and it will always be correct. I plus 1 on this line is 1. When I is 1, 2 stars. Beautiful. Isn't that nice? So that's what we can repeat. This can turn into our inner loop, right? And this is fancy, because now our inner loop is going to depend on the value of the outer loop's variable. All right, that's the key new thing for triangles. We need that now. Okay, so let's see. Let's start with all this. So there it is. And now, all right, so what am I repeating now? It's not print 4 stars in a new line. It's going to be, I'll keep that like that. It's going to be print I plus 1 stars in a new line. Do you see that? That's what I repeat. That's what I must do. That's what we just figured out. All right, but it's still 4 lines, so like, this is fine. All right, because the inner loop is all about figuring out how many things to print. Like, let's translate this now. This is what I need to translate to code, and that's my body. For int j equals 0 again, and the idea is we want this to execute instead of j less than 4, j plus plus. I guess, here, let me go back. Let me steal all this again, because I'll need most of it. So this is going to print 4 stars in a new line right now, right? Do you see the pattern here? So if I want this to print 4 stars in a new line, it's like this. If I wanted to print 3 stars, it's like that. 2 stars, it's like that. 1 star, it's like that. If I want it to be I plus 1 stars, then it's like that. See it? So that's what you do. That's the trick there. So this will print I plus 1 stars, and then a new line now. So this is another good example to take to the C++ tutor website, to just step through it slowly to make sure you understand it. But there it is. There is our left-leaning right triangle. It's beautiful, isn't it? And of course, you can make this longer by changing this. Change that 4 to something else. That's pretty cool. All right. Yes, that's a good example. And notice this is a very key brand new thing. We're using the outer variable, or the outer loop's variable, to control the inner loop, changing how it works. That's very, very powerful. Okay. And yeah, I think that's what I wanted to show you there. So all of these facts we got out of just this idea. Just this idea that like the inner part of a loop gets like it multiplies the work that's being done of each of its outer loops, right? Each of the things, the loops that control it. So yeah, multiplying work gets you pretty far. One other thing that this loop does that I didn't talk about yet is, do you see, I guess I did say it just briefly, do you see how this is ranging through every possible combination of 0 through 4? Like I is ranging from 0 through 4 and j is ranging from 0 through 4. And like in here, each different value that we print is every different possible combination of 1 through 4. Does that make sense? Or sorry, 0 through 4. Every possible range of values. We're trying every single one of them. That's what nested loops can do for you. All right, that's another thing that they can do. So that's a new key idea. Nested loops are trying every combination of values. Like you got 0 through 4 here, you got 0 through 4 here. You do it twice, nested, you're getting 0 through 4 every combination, right? 0, 0, 1, 0, 1, all the way to 4, 4. That makes sense? It's trying every combination of, for the first number 0 through 4, and also for the second number 0 through 4. Every possible combination. And we can do cool stuff with that fact too. All right, so that's another thing that nested loops can do for you. One thing that I'll show you is called a brute force algorithm, right? It's a kind of funny name, but a brute force algorithm is just like you're throwing the computer at the problem because computers are fast, all right? So a brute force algorithm is where you don't really think. You're using brawn instead of brains, I guess, all right? So it's just trying every possibility. It's not trying to be fancy or think about how to solve the problem efficiently. It's just like throwing the computer at the problem. And computers can do a lot of stuff very quickly. They can do like a couple billion operations per second, so it works for smallish problems. It should be fine. So here's a fun little example that will lead to a brute force algorithm that's easy to explain. All right. So here is a silly word example. All right. Here's the setup. Here's the story. So let's say that we live in a universe where horses cost $10. That would be nice, right? Pigs cost $3, and then rabbits are on sale today. They're 50 cents a piece, okay? And then let's say that we know that in this universe, a farmer bought 100 animals for $100. That's what she told us. And she's like, I bought exactly 100 animals, and I spent exactly $100. The question is now, how many of each animal did that farmer buy? Okay, there might be multiple answers, and we can discover all of them using this idea of nested loops, all right? Do you see how I know that she bought 100 animals for $100? Like, let me just range through every possible combination of horses, pigs, and rabbits. Do you see that? Like, I'm just going to be very lazy about the problem. I'll just be like, all right, 0 horses, 0 pigs, 0 rabbits. Maybe 0 horses, 0 pigs, 1 rabbit, all the way to she bought 100 horses, 100 pigs, 100 rabbits. Do you see how if I enumerated all of these possibilities, somewhere within them is the answer? Does that make sense? That's the secret. So I need a triply nested loop, don't I? A triply nested loop to like try all the different combinations of 3 separate values. Because like she could have bought how many horses, right? I'm just throwing the computer at the problem. I'm not thinking about it. Like, all right, she could have bought 0 horses all the way to she could have bought 100 horses, inclusive, right? That could have been all that she bought. I know that's too much, but I don't care right now. I'm just going to try every possibility. So num horses can range from 0 to 100. Same with num pigs. These will be my variables. She could have bought 0 pigs. She could have bought 100 pigs. Who knows? Anything in between, right? We want to try every combination. And then num rabbits as well. Rabbits. That's a bad-looking R. That's still a bad-looking R. It happens. That could also, she could have bought 0 rabbits or 100 rabbits. Who knows? But some combination of these 3 things with those ranges of values, somewhere within them holds the answer, right? I hope that makes sense. So this leads to then, if I want to do this kind of try all the possibilities, just like this was trying all the possibilities of 2 numbers, it's a doubly nested loop. If I want to try all the possibilities of 3 numbers, just like this, it's going to be a triply nested loop. Triply nested loop to try all the combinations of those 3 separate values. Let's write that. To try all the combos, I guess. Less writing for me. All the combos of the 3 numbers. Okay? Let's do it. And this is a fun one. Let's see. I'll call this brute force. It's a brute force algorithm. We're throwing the computer at the problem rather than thinking hard about it. All right, so triply nested for loop. So num horses can range from 0 to 100. Let's go. For int num horses could be 0 all the way to 100, right? Num horses plus plus. Cool. I'm doing the same exact thing for pigs and for rabbits, aren't I? So num pigs inside of that. Like, I picked a number of horses. Now let's try all the different possibilities of numbers of pigs for that particular choice of horse count. Boop. And then same for rabbits. Boop. And here. There. And then I need a few more braces. So this is moving there. This is going there. There we go. So here we go. A triply nested for loop, ranging over all the different values of numbers of horses, pigs, and rabbits. Because it's nested, that's going to try all these possibilities. It's a lot of them. But the computer's pretty fast. It'll do it. All right, so within here, right, in the innermost body, what has happened? I've made some choices, right? Num horses is set to something, pigs is set to something, and rabbits is set to something. I'm going to eventually hit here for every possibility within the ranges I care about. But let's think about what we have when we're here. When I am here, I have chosen, right? The computer has chosen some amount of horses, pigs, and rabbits. Every possibility from 0, 0, 0 to 100, 100, 100, for the reasons that we've talked about, will get a chance, right? Every possibility will get a chance. I think that's it, all right? And so, all right, I'm in here. Maybe it's 0, 0, 0. That's not going to work. 100, 100, 100 is also not going to work. But somewhere in between will. And so let's keep track of what's happened. So I've made some choices. I've chosen an amount of horses, pigs, and rabbits when I'm in here. And I'm going to try every possibility if I go through here enough. And so, like, when I'm here, I've bought a certain number of animals, right? Num animals. It's just however many horses, pigs, and rabbits that I've chosen. Num horses plus num pigs plus num rabbits. A lot of the time it's not even going to be 100, but that's fine. Eventually it will be. Sometimes it will be. And then I've spent a certain amount of money, right, on all of these animals. Because essentially I'm looking for this, right? I'm looking for the case where it was $100 for 100 animals. So, like, let's keep track of the price now. Because, again, I've picked a certain number of horses, pigs, and rabbits right now. Let's see what their price is as well. Double price. Like, for whatever they are, the price is going to be... Here, I guess I can do it this way, can't I? It's num horses times their price, right? However many num horses is right now, that's how many I've chosen, or I'm pretending to choose. And they're $10 a pop. So times 10 for them, plus num pigs times their price, which is $3. And then rabbits were 50 cents. Yeah? And so that's num animals, that's price for whatever my choices of these three values is right now. And so now I just need to see, does that satisfy the question? Were there 100 animals and did it cost $100? All right, so if that's true, if num animals right now for my choices is equal to 100 and the price is also exactly equal to $100, I told you that you should never check doubles for equality, didn't I? And here I am checking doubles for equality. So what you should be doing, this is a case of, like, I know that it's going to work right now, but you should never bank on that. Once you get a computer science degree, once you get your bachelor's in computer science, you're allowed to bend the rules like I am right now, but not until then. Until then, you should be doing the subtraction and the absolute value because you're not sure, like, this is going to work. I am sure that this will work, and I know why, all right? So this is one of those do as I say, not as I do moments. But, all right, if that's true, then that's a solution, right? I found a solution. Those are the values. So let's print out our answer, because there might be multiple. So, all right, that means pick this many horses. Num horses, horses. And then num pigs, pigs, right? And then finally, num rabbits, rabbits. And then I think new line will be just fine. There. So yeah, it's hard to show you this all on the same screen, but that's the loop, right? I'm iterating through every possibility, every combination of horses, pigs, and rabbits. That's what the nesting gives to me. And so everything from 0, 0, 0 to 100, 100, 100, and everything in between. Sometimes the number of animals will be 100. Not very often, but sometimes. And then the price will be whatever this calculates to be. And then our solution is if this is true, right? We bought 100 animals for $100. So let's see what our solutions are. Drum roll, please. Let's make sure there's no compiler errors as well. Looks like it's all right. Wow, there are 2 solutions apparently. All right, and so notice how first of all it's saying that these all added to 100, right? 20 pigs plus 80 rabbits, that's 100. This is also adding up to 100. There's 2 different ways that the farmer could have done this. All right, now we know. We'll have to go and check and see if she bought any horses. That'll tell us, right? So here we go. We can check this answer, can't we? Like, don't buy any horses. 20 pigs is $3 plus 80 rabbits times 50 cents, right? That's 100. That's perfect. Or 5 horses, so that's $50 plus a pig for $3 plus 94 rabbits for 50 cents each. That's also $100. That's perfect. Cool. So those are the 2 solutions to this particular problem, and we solved it with brute force. We used the fact that nested loops try all the possibilities, everything in between, all the different combinations of 2 numbers, or 3 numbers in our case, right? So yeah, that's a fun example that I love to talk about and to give in class. You could improve this. Brute force just means you don't think. You could think a little bit more, and still keep it kind of like this. One thing you might notice is you can solve this problem without the 3rd loop. You don't actually need 3 loops. If you've taken a statistics class, the right word to say here is there are only 2 degrees of freedom to this problem. Once you've picked how many horses and pigs you've chosen, because you want it to add up to 100, you kind of know immediately how many rabbits you must buy right now. Okay, so that's why you don't actually need the third loop, and that will make it run faster, even though it ran in less than a second. But that's one thing you could do, and yeah, you could think harder about the problem, make it faster. But like, I think this was the easiest way to show you first, and it still worked. All right, so that's that. Nested loops, very, very important. All right, so with that in mind, it is hard to stare at this and understand it the first time you're seeing it. All right, I know. So I've definitely been there. I want to give you as much practice as possible. Please stare at my code that I give you after class and go through the examples yourself and yell at me when you get stuck. But another cool thing that you could do, another useful thing that you could do, is to do this kind of translation that I was doing before. All right, so let's take this code that has a nested loop in it and translate it to a flowchart diagram so that we can prove to ourselves we understand how this code will run. Okay. So let me walk you through how I'm going to do it, but it might be helpful for you to pause the video right now and try it yourself. But yeah, the very first thing in this code, I'll show you how I think about it and talk it out loud, talk you through it. So we start at the before code, right? That's the very first thing that happens. And we're definitely going to end at the after code. We start at the before, and then we see this while loop, right? How do while loops work is now the question. Well, they run their condition, and as long as the condition is true, they run their body. Yeah. So the next thing that must happen, always, is we check A. A question mark, is it true or false? If it's true, we run that body, right, which is some big long nested loop. If it's false, we skip over the whole loop and we go straight down to after, don't we? So that's an easy one. Let's do that over here. After. Boop. So if it's false, we go way down to there. Call it a day. But as long as it's true, we're going to run the body and come back to the condition. That's what this while loop does. All right, so if it was true, if A was true, we are now running the body of the while loop, aren't we? And that just happens to be another loop. Oh, goody. So now we just have to run this to completion, right? That's our job. So how do you run the for loop is now the question. Well, it's got an initialization. You're going to run that. So that's part B. That only happens once. And then it's condition body increment as long as the condition is true. So it's C question mark is now what we do. B is first always, and then we never repeat B. Now it's condition. If it's true, we run the body, right? Body and increment. So if the condition was true, we run E, then D. In that order always. E, then D. And then we come back to the condition. That's what the inner loop does. It keeps on repeating condition, body, increment, as much as it can until the condition is false, all right? And then once the condition is false, all right, we stop the for loop. It's done. It's finished. What does that mean for us, though? It's essentially us completing the body of the outer loop, right? So what that means once we get here then is I've completed one iteration of the while loop. I'm coming back now to A. I need to go back to A to check it again because maybe I need to run the body again. So it's always condition body, condition body. The body is just complicated, all right? So whenever this is false, we're coming back to here. That's what it means to be done with an iteration of the while loop's body. We come back to the condition check. So that is, in flowchart form, how this program will run. Do you see kind of how it's going to usually work? It's like, all right, it's going to run the inner loop a few times, it's going to run the outer loop a few times, which involves running the inner loop a bunch of times, right? So that's one iteration of the outer loop. So you got the inner loop going some more times. You're going to run like that, essentially, until that outer condition is false. Then you go to after. Okay? That's the best I can draw, I guess. But think about it. I hope you kind of see it, right? And another helpful thing would be to go and like make some real code here and step through it on that C++ tutor website. It's a very, very useful website. All right, but that I think that's where I want to pause today. There's more to nested loops. I want to show you more examples, but this is definitely a difficult concept. So I want to give you some time to breathe now and just process everything you've learned. So the last thing I want to do before we go is here's a meme that my old boss sent to me, and it goes along with nested loops, doesn't it? Right? It's telling us that nested loops multiply work. So like here are your 3 different options in the outer loop. Here are your 3 different options in the inner loop. When you bring them together, you suddenly have 9 options, don't you? All right, so that's a fun thing to end on. And yeah, I have a couple more slides for loops. I'll show you a very cool thing, and that will lead into a future lab. But we are not ready yet. I want to give you some time to breathe. So yeah, we'll come back. And I will see you in the next lecture.